Okay, this is problem 54. It wants us to factor this polynomial into a product of two polynomials, a times b, where the degree of a is greater than the degree of b. So let's try factor by grouping, because that's the only method we have with a cubic like this. So we can pull out the biggest number we can pull out of 25 and 40. It would be 5, so let's pull out a 5. We can also pull out x squared, and that leaves us left over with 5x plus 8. All right, let's do the same thing with the next two then. We're just factor by grouping, right? We group together the first two, and now we're doing the second two. We can pull out an 8 from the second two, and that'll leave us with 5x plus 8. Okay, it turns out that that's good. We can pull out this 5x plus 8 from both and put that out front. 5x plus 8 times what's left over, which would be 5x squared plus 8. Now it wanted us to, it said a is the greater degree, so this is going to be a right here, and this is going to be b. So we enter in 5x squared plus 8 here. Use the caret thing. And we enter in 5x plus 8 here. The next one wants us to factor again. We're factoring this trinomial now. Now you can guess and check if you want. It tells us your answer can be written as 5x minus, so they actually give us some information here. So I'm going to guess and check because they give us one of the pieces right there. So 5x minus something, and then I have another factor here. So what times 5x gives me 20x squared? That means this has to be 4x right there. And so now I only need to guess and check on these two. So what two things multiply together to be negative 20? So I'm going to do, I'll try 4 and 5 first and see if that works. And it looks like that works. So when you multiply this out, the middle terms become 25x, and the other middle terms minus 16x, which gives you that 9x that we need in the middle. So this is the right factorization. They want b is 4 then, c is 4, and d in this case is 5. Okay, so the next one then says factor this trinomial, and it tells us that it's going to be a perfect square trinomial. That's what this is. There's two things that I want you to remember. A difference of two squares, which has the pattern of like x minus 2 times x plus 2, and that will turn into x squared minus 4. It's a difference of two squares. And the other thing is, like, if you have x minus 2 squared, that's a perfect square trinomial. That'll turn into x squared minus 4x plus 4. So there's a perfect square trinomial and a difference of two squares. Those are the only two that you'll have to memorize this class as far as factoring patterns that come up over and over again. So definitely memorize these. This was the perfect square trinomial. So basically we know that we have to have 4x. We have to have two factors that are the same. So 4x minus 4 and 4x minus 4, or just 4x minus 4 squared. Because all you do is take the square root of this and put it here, and the square root of this and put it there. I use the negative sign so that the middle term will be negative 32. And that's all they want. So a is 4, and b is 4. Okay, that's another one that says factor completely. So we're going to try to do factor by grouping. Since we have 4 terms, we have a cubic function. That's the only thing we have to do at this point. That's the only thing we know how to do. So that'll be x, if I pull out an x squared, that'd be x minus 7. If I pull out a negative 4 from these two terms, I'll have left over x minus 7. So then I can pull out the x minus 7, and I'll have left over x squared minus 4. So that's what they're looking for here, x minus 7 times x squared minus 4. All right, the next one says factor the difference of two squares. This is a difference of two squares, so all I have to do is take the square root of both of these. This would be 4x to the 5th if I took the square root of it, minus 5. And then you do the same thing, it's 4x to the 5th, but this time plus 5. So that's the other pattern that we talked about, where it's basically like x minus 2, x plus 2, which turns into x squared minus 4. Well, that's the same thing we have here, only it's a little bit bigger, right? So we have the same pattern here. You take the square root of this and put it here, square root of this and put it here, and you just change the sign between the two factors. Same thing here. Square root of this, put it here, square root of this and put it here. And just change the sign in between the two factors. Now, the square root of x to the 10th, I knew that was x to the 5th because when you raise it to the 1/2 power, which is the square root, that's how you get that x to the 5th right there. So this is my answer that I'm looking for. I know it's a little bit more difficult to enter that in with the caret right here, but that's the answer. All right, next problem says factor out the greatest common factor. So all you have to do is pull out the biggest number you can, which is 5, and the biggest variable you can, which is t cubed. That'll leave you left over with 3t plus 2. And so factor out the greatest common factor, I think they want you to write 5t caret 3 times parentheses 3t plus 2. Okay, the next one's another factor by grouping ones. We're going to group the first two terms and group the second two terms. Pull out the biggest thing you can from the first two, which would be 5. We can also pull out a z from the first two, and that would leave you with 4x minus 5y. And then the next one, it's 4x minus 5y, but I can't pull anything out. So I'm going to write a 1 outside just because you can do that. And then I can pull out the factor. So it's going to be 4x minus 5y. I pull that out times the other factor, which is 5z plus 1. So that's my answer right there. All right, so the next one's another factoring. We got a trinomial here. It's a 4th degree, but we can still factor it into two probably quadratic factors. So let's just try guessing and checking. This one looks easy enough. If the first or last term is small enough where it doesn't have a lot of factors, guess and check is quickest. So let's do 5 and 3, 5x squared and 3x squared. And then we'll do like minus 1 and plus 1, or minus 1 and minus 1. Minus 1 and plus 1. Let's try that. Checking the middle terms, so 5x squared, and then minus, yep, that works right there. So we guessed, and the first time we got it right. So just a reminder on guess and check, you just want two things that multiply together to be the first term right here. And then you want two things that multiply together to be the last term right here, and then check to see if the middle term works out. If not, you're going to have to try guess and check in different factors. Next problem is the distance formula. Distance formula is square root of the difference of the y's squared plus the difference of the x's squared. That's the formula. So in this case, that would be 4 minus 2, which is 2 squared, plus 3 minus negative 1 squared, which double negatives go positive, so that ends up being just 4. So I'd have 4 plus 16 square rooted, which is the square root of 20. So I would enter that in square root of 20. It'll also accept if you reduce this, square root of 20, you get 2 square root 5. So if you say that, if you say 2 square root 5, it'll also accept that answer. The next one says, from your campground, you walk 1 mile east. So here's the starting spot, let's say, right here. We're going to walk 1 mile east, so I'll say that's this far east. Then we're going to walk the square root of 2 miles northeast. So we're going to walk the square root of 2 miles northeast. And then 2 miles south between you and the campground. The distance between you and the campground, which is what it's looking for right here, is now what? Well, first of all, we can recognize some things here. This is a special right triangle right here. This is a special right triangle because the hypotenuse is the square root of 2, and we go at a 45-degree angle. If you remember your special right triangle values, this was x, and this was x square root of 2. So this is like 1, because if that's square root of 2, there's a 1 in front of here, so x is 1. So that's 1 right there, if you remember your special right triangles. And then this has to be 1 as well then, because this whole distance was 2, so that has to be 1. And this was 1. So we know basically we have a new triangle right here where this is 2, this is 1, and we're trying to find the hypotenuse of that triangle basically. I'll call that C right there. So to do that, let's just do the Pythagorean theorem. A squared plus b squared equals c squared. 1 squared plus 2 squared equals c squared. That's going to be 4 plus 1 is 5, so the square root of 5 is our answer. The next problem, if we're going to find the perimeter of a triangle, we just graph these 3 points. You don't really even have to graph it. Just find the distance between all 3 points and then add them together. So you could use Pythagorean theorem, obviously, but the distance formula, once again, is the square root of the difference of the y's plus the difference of the x's squared. And I'll pause it and I'll do this for these 3 points real quick. I'll call this point 1, 2, and 3. So the distance between 1 and 2, distance between 2 and 3, and the distance between 1 and 3. I'll do it real quick for you. So here's the work for that. You can pause and check that out if you want. But if you go ahead and enter that in, you can just enter it in as adding those together, and it'll accept that answer. This is definitely the toughest problem in the homework. It's basically saying that if you have a line, y equals x, which is this line that goes down a diagonal, you want to find some line, some point on that line that's equal distance from the point 2, 3, which is up here, let's say, and 3, 9, which is way up here. So basically that point's going to be somewhere around here. I don't know, somewhere around there. Now, to do it, I'm not going to use a graph. I'm going to use my knowledge of the distance formula. I'm going to call this point xy, wherever this point is. And I'll just do the distance formula from this point to that point xy, and from this point to the point xy. And I'll just set those equal. So the distance formula between 2, 3 and this point would be 3 minus y squared plus 2 minus x squared square rooted. And the distance formula between 3, 9 and the point xy would be like y minus 9 squared. Order doesn't matter when you're doing this as long as you stay consistent. X minus 3 squared. And set those equal. Now I would square both sides. 3 minus y squared and FOIL. So let me do that as well. Now I'm going to run out of time in this video, so I'm going to do this step and pause it. Okay, there's the work if I get rid of the square roots and FOIL everything out. Now I can simplify some things. X squared cancels x squared. This y squared cancels this y squared. Now I can add the numbers together. 9 and 4 is 13. Minus 2y minus 4x. And then over here, add the numbers together, and I get 90 minus 18y minus 6x. And now just simplify this. So let me just add like terms. All right, I just moved the 90 over and then moved these two over to the right, and I got this. It doesn't matter how you write this. You have an equation with x and y, and the other equation you can use is x equals y, because we know that if our point's on this line, x always equals y. So that's our second equation that we're going to set, use with this equation, and we'll substitute. So that gives us negative 77 equals negative 16x minus 2x, for example, to put x in for y. So it'd be negative 18, x equals negative 77, and our answer then would be x equals 77 over 18, and y has to be the same thing, so that's our answer. And I made a mistake right here. This, when I FOILed this out, this should have been right here 6y, negative 6y, in which case this would have been negative 6y. When I added it, this would have been negative 12, and this would have been negative 12. This would have been then 14. So this should have been 77 over 14 for my problem. It's easy to make small mistakes like that. Okay, next problem is the midpoint. It says the midpoint of this is 1, 2. So the midpoint formula is x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. So it gives us the midpoint, in this case 1, 2. And it tells us we don't know what b is. We'll call b xy. So that I'll add 3 plus x over 2, comma 9 plus y over 2. And then I only have two missing points, x and y here, to find point b. So we just filled out the midpoint formula. And I'll set the x coordinate equal to 3 plus x over 2. Multiply both sides by 2. And subtract 3, x is negative 1. And then I'll do the same thing for y. I'll set 2 equal to 9 plus y over 2. Multiply both sides by 2, that's 4. Subtract 9, that's 5. Negative 5. So there's my point B right there. Next problem wants to do the distance formula real quick. I'll pause and show my work. That would be 10. Okay, then it wants the x co-coordinate of the midpoint of the line segment that joins them. So let's do the midpoint formula, which is just add them and divide by 2. So 4 plus negative 6 is negative 2 over 2. And negative 3 plus negative 3 is negative 6 over 2. That simplifies to negative 1, comma negative 3. Next problem wants us to match the set of points indicated by the order pair with the correct quadrant the point lies in. All right, first one, if x is equal to 0, then obviously we're on the y-axis somewhere. All right, if x is greater than 0 and y is greater than 0, we're in the first quadrant. And then if y equals 0, we're on the x-axis. And then the last one, if x is greater than 0, or if x is less than 0 and y is greater than 0, we're in quadrant 2. All right, the last problem is see which one's closer to the origin. Do the distance formula from, this is Distance formula from A to the origin and from B to the origin. Turns out B is bigger, so A is closer to the origin.